Okay, so you can't get in yet? So I'll start talking, and so the point of this question isn't to kind of rub it in. It's actually as a lead into our topic, which is addiction. So if you think about quizzes, you know, like there is actually a more popular, more positivity in these responses than I was expecting. But you can imagine, for example, you know, generally you're not that excited about quizzes. I think I'm safe in saying. However, what if every time there was a quiz, you know, like you had, say, a very tiny chance of winning $1,000? What would you do? Would you sort of like to take quizzes then? What if you could take? What if you could keep taking it, sort of keep taking quizzes, sort of like, you know, like many times an hour, and each time you had this tiny chance of a payout? No. But if it's multiple, what if it was multiple choice? So, what's that? Yeah. So the whole point about sort of like, you know, your attitude to the quizzes is that they, you know, have like a little bit of a negative side to them, right? Because it's like you don't want to do badly, and the only positive side is that sure, they sort of probably do help you study the material. If they came with this sort of like just very faint chance of sort of some major reward, you might get much more into sort of taking these quizzes, right? And then you might want to take them again and again, which is what kind of, because you'd have some kind of reinforcement, and that's what kind of leads into addiction. Yes. I am not saying that, no. Nice try, though. I'm recorded. So that's a lead into this subject for addiction. And we will be talking about serotonin and dopamine. And so I, you know, like would start off by discussing, you know, what is addiction? So usually we're going to be thinking about, you know, like addiction to sort of substances when we talk about addictions. So for example, there's an estimated sort of 23 million Americans 12 years or older have a significant problem with alcohol or drugs. So that's a, you know, like a big chunk of the population. But that's, you know, like only two specific things, right? That's only talking about addiction to chemicals. Yes. That, yeah, what's the current population? Like 350, something like that? Yeah, something like that. So yeah, it's like probably at 8 o'clock in the morning, I'm not going to do the mental arithmetic, but I'm guessing around, yeah, like 6-7%, something like that. But almost anything can become addictive, whether it's sort of gambling, which is why I had the idea of, you know, like if you had quizzes where there's this tiny chance of a cash payout, you might get more into it. And even things like activities which are sort of produce a huge adrenaline boost can often become addictive. And so really, when we're talking about addiction, you're looking for something that the person who is addicted will lose, you know, self-control and will completely disregard the risks and consequences from whatever activity it is. In many cases, it will involve a kind of ritualization of the activity. And in general, when we're talking about addiction, you're going to be concerned about it being sort of maladaptive, i.e. it has sort of, you know, like negative consequences for that person. So obviously it does include drug addictions. And in general, sort of with drug addiction, and that we'll kind of get more to that in the second half of today's class, you're looking at sort of an acute high plus, in many cases, physiological dependence, which actually, you know, makes it even harder for someone to, once they're addicted, to stop taking that whatever substance it is. Alcohol dependence is a little bit of a special case, because it's so prevalent and so embedded in many cultures. And so alcohol dependence can range from, like a very mild behavioral dependence where, like someone, like needs to have a glass of wine every time they get back from, work or school or whatever, to sort of, like full on alcoholism where it's, like practically destroying their body. And there's sort of a big continuum. And in many cases, this can be tied to sort of lifestyle and, socializing. And then there are also many compulsive behaviors. So there's sort of risk-taking where someone becomes addicted to the sort of feel of the sort of like adrenaline rush. Gambling. There's something that's increasingly being at least talked about in the news is sort of video game addiction. And in many cases, so there was a case where, well, not so much a case, an interesting article I read like a while ago about a game, I think it was called Destiny. And they employed psychologists in order to sort of tweak and insert as many behavioral cues to create sort of addiction within the game in order to sort of make people sort of more, like driven to sort of keep playing it.
Wow, that's kind of cool story.
And if you think about the sort of free-to-play games that you sort of they have on particularly phones, those are now like big business because they can sort of extort money out of especially kids to persuade them, by just paying that sort of like dollar to unlock the next level. You pay that dollar sort of like hundreds of times, and it sort of adds up. Yes.
To be fair, I spent 1 year making games and it sucks.
You did.
It's very hard to make it.
Yes, I can. So you're not thinking everyone should quit pharmacy school and start making a free-to-play game and get rich? Yes, definitely. The other area where gaming has been linked to addiction is in these sort of massively multiplayer online games where the sort of virtual social side of it takes the place of the actual social side of someone. And this seems to be, I think, is just worst cases of this currently, and I think it's in particularly in South Korea, where they have these sort of internet cafes where people actually do literally spend all day like sort of playing them just in order to sort of like get these microscopic advances. Yes. Yes, absolutely. Yes. So it's like these are sort of examples of addictive behaviors. There are people who have sex addictions. There are addictions to over or under eating, which in fact we'll talk about, I think is it Friday or Monday, in eating disorders. There are people who have shopping addictions. And there are people who have exercise addictions, where it's, like they're not exercising because they like just enjoy the feeling, they become obsessed by it. Yes. Uh-huh. So that is, well, I mean, we'll talk about it more in that, but yes, it's because you can't be addicted to not doing something, but you can be addicted to any feature of something. So in the case of someone who's they have it's beyond the scope of, well, we wouldn't get to the rest of this class if we talked about it now. But so for example, if someone has a very distorted self-image and then they feel that they just need to sort of do a little bit more dieting, and then they'll like fit into those sort of Barbie doll size pants or whatever, like so there's this reinforcement coupled to sort of self-image that sort of leads someone to like so that they look in the mirror and they're sort of like skeletal, but they think, man, I look good. And so it's that decoupling from reality, really, but or at least a healthy body image that leads to the sort of under eating being something that you could become addicted to. And it's also related to addiction to, many of these things are related to addiction to control. Because, you know, everyone wants to have control over their environment. And so this is actually, I think, related to the, especially, well, things like gambling and video games and all these things, there's an element of addiction to control. Because, you know, like say, you can't control everything in your life, but someone who's addicted to slot machines know that if they just put in that extra roll of quarters, they will strike it big. So they're trying to find some control in many cases in life, and that's what's becoming, you know, like reinforcing. So almost anything can become addictive, and the issue is basically whether or not it's becoming problematic. And this also ties into sort of social acceptability. So nicotine and alcohol, for example, both have very strong addictive properties. Also, both of them are, at least to some extent, socially acceptable. Things like gambling and gaming are psychologically addictive. There's obviously no chemical involved, but also, you know, like have some, you know, like different levels of social acceptability. Whereas drugs of abuse have, you know, like varying levels of psychological and physiological addiction, but they are not generally socially acceptable. So how things become addictive ties into something that's often referred to as the reward pathway. So every organism, in order to survive, has to, you know, meet its physiological needs, right? So you know, like, you know, everything has this desire to eat, for example, you know, however it does it. And so if you're a really simple organism, then you don't really have, there's not much sort of thought process about it. You know, like if you're a bacterium drifting around in a solution and you come across a food substance, you just engulf it and you don't say, man, that tasted good. You just, you know, like it's just automatic. If, you know, like even like an ant isn't really, I think, considering, you know, like its menu options. But as you sort of get into more complex organisms or more complex nervous systems, there becomes this sort of element of, you know, like, you know, there are more complicated neural circuits that are involved in this. And so this is where sort of you start developing behaviors. And so as soon as you have something that's really behaving, depending on how it's feeling at that moment, you also need to, you still need that creature to, you know, meet its biological needs. And so that's why, you know, biology has developed motivations. You need to sort of develop fears to sort of avoid dangerous things, and you need the opposite of fear, sort of some kind of reward system to reward the organism for seeking out things that are good for it. And so things like food, water, sex for procreation of the species, nurturing, you know, like familial or social relationships, are all things which give activation of reward circuitry. And the purpose of that is to reinforce those positive behaviors in order to sort of, you know, make the individual carry them out. In general, these are, in mammals at least, these involve dopamine and serotonin. And so, and we have these particular neural circuits. So we have the serotonergic system, and that's entirely comes from these handful of nuclei in the upper brain stem called the raphe nuclei. And that is the source of all of the serotonin that projects throughout the brain. And then we have a couple of dopaminergic systems. So we have the one that we've talked about for Parkinson's disease, the substantia nigra projection to the striatum. Nothing to do with reward or motivation. But we have this ventral tegmental area that projects to the frontal cortex and also projects to this other area called the nucleus accumbens. And so the projection to the frontal cortex is thought to drive the sort of craving activities. So like, like basically motivation. And the serotonergic pathways are involved in mood, including satiety. So, like satisfaction. And then this dopaminergic projection to the nucleus accumbens is thought to provide the actual reward. So, reward is better than just satisfaction. It's a, actual pleasure. So dopamine is then responsible for motivating us to do what we need to do to meet our needs. And then we get release of serotonin, which is responsible for giving us our feeling of satisfaction. If we have low levels of serotonin, i.e. low satisfaction, the motivating effects of dopamine are amplified. They become stronger. So this makes sense from the point of view that, you want, if your body is telling you you need to eat, you don't want to sort of feel, well, I'm pretty happy, I'll just skip eating today. So, you need to have that sort of reciprocal regulation of craving versus satisfaction. However, different other extraneous factors also regulate your overall mood and satisfaction and so on, like stress, for example. So if you are in a high stress situation, then the craving feelings get stronger. And there is this reciprocal relationship between serotonin and the dopaminergic neurons that are projecting to the prefrontal cortex. So that when you have lots of serotonin, those dopaminergic craving neurons are inhibited. And you can actually pharmacologically block those serotonergic receptors, and that will lead to someone who is basically no longer, hungry or anything else. They'll just sort of be perfectly content while they kind of waste away. So, and this is one of the reasons that, some drugs that act on serotonin signaling will actually lead to weight gain. And so this is a sort of significant issue for a number of, say, antidepressant drugs. So that's the balance, or at least a summary of the balance between sort of craving and satisfaction. Sort of, it's just dopamine and serotonin. But obviously, you're all aware that sort of there are better things in life than satisfaction. Whatever the Rolling Stones said. And so that is why we have the sort of other reward pathway. And this involves this dopaminergic projection from the ventral tegmental area to the nucleus accumbens. And this is also the pathway that involves the endogenous opioid signaling. And the endogenous opioid signaling that's, as we'll talk about, is thought to be the reason why, people take things like heroin. That's basically regulates this dopaminergic reward pathway. So if you are activating the opioid system in the brain, you more strongly activate this dopaminergic reward pathway. And if people did experiments with rats where they sort of had little cannulae in different brain regions, and so if you let a rat control the release of mu opioid agonists, then they will just do that to the exclusion of everything else until they die, because it just sort of is like perpetual sort of reward for them. Equally, if you infuse an antagonist to the mu opioid receptors into the ventral tegmental area, then actually it blocks any addictive effects of opioids, because you're just blocking the targets. So it's the reward side of this is all down to this ventral tegmental area nucleus accumbens connection mediated by dopamine. Yes. Yes, that's in the eating disorders lecture. But yes, Yes, yes. So unfortunately, if you can't use leptin to lose weight, though, it's the downside of that. But yes, absolutely. So yes, the leptin is the essentially the signal from the fat cells to the brain to tell it that it needs more nourishment. So well, it's not separate. Well, it is separate, but it's the brain itself obviously can't make the decision that it needs food because it needs some signal from the body, and the leptin is that signal, or a major part of that signal in terms of so it's very much connected as far as eating goes. We're just like one step further into the brain and not concerned about the sort of out at this point. We're not concerned with outside of the brain. No problem. So yes, so this is just a diagram of showing you where where the mu-opioid receptors are, this ventral tegmental area, and connecting to the nucleus accumbens. So to kind of summarize, compulsive behavior is like this kind of there are all these different types of compulsive behaviors, whether they're sort of risk-taking or gambling or eating disorders, etc. All of these are using this dopamine serotonin system for craving and satisfaction, and then the dopaminergic system regulated by opioid receptors that drives reward. And for most behaviors, there's a pretty small reward, right? You don't sort of if you have a bite of something that tastes really good, yes, it does taste good, but you're not going to sort of devote your life to sort of recreating that bite. But every time that there's some kind of positive activation, you get a level of conditioning and synaptic plasticity, and you can end up strengthening those pathways. And so if they start becoming, very greatly strengthened, like you start feeling that, sort of jumping out of a plane, like that rush of adrenaline is just so awesome that you just can't wait to do it again. And then you do it again and again and again, then it becomes an addiction because you've just reinforced that pathway so strongly. And yes, I saw you shake your head. I don't like heights either. So,
I don't care about heights. I don't like the feeling of falling.
Okay. It's a hitting I thought that was bad.
Yep.
But so the only problem when you have these sort of reinforcing links is that they get stronger and stronger with repetition. And so once it starts, so the only ways to sort of deal with that are, well, the most effective way is preventing the establishment of this sort of addictive cycle. And once you have that addictive cycle, then you have to have some way of dealing with it, which might, for example, be using some of these drugs that actually block opioid signaling, for example. And so now you can summarize this, what we talked about the last little section, and we have time for the thing I'm addicted to now. Calling on people. Kevin Lee, come on down. For yeah, like addiction and craving and satisfaction. Yes, so the dopamine projecting to the prefrontal cortex is creating the drive to go do the particular behavior, and the serotonin is saying sort of like, satisfaction. But there's the additional reward pathway, which is yes, and that's what gets, kind of as we'll talk about, is what gets hijacked in especially a lot of drugs of abuse and stuff. Yes. Stress decreases serotonin. So same idea, but like opposite way around, or at least that's the thought. Yes, certainly amplifies the motivational effects of cravings. Yeah, serotonin makes you not want things as much because you're content. So it's like serotonin is like the content neurotransmitter, and dopamine is either the craving or the reward neurotransmitter. What's that? Sorry. Yes. So yes, if your serotonin level drops, then you'll be more vulnerable to sort of addictive behaviors. There are. So actually, well, yeah, like meeting. So the circuitry is complicated, but and where serotonin gets released depends. But basically, it's by you're aware that you're so you have this. So it's not just that you're sort of like someone would be putting a drop of dopamine in your prefrontal cortex, and you'd say, "Yes, I need to go jump out of a plane." So you're aware of what it is that you're craving, and by meeting that craving, you're then triggering the release of serotonin, sort of in certain areas of your brain. Right, exactly. Though maybe if you had perfect meditation abilities, you would be able to. So we're going to talk a little bit now about, we may not be able to finish before the quiz, about sort of chemical addictions specifically. And so there are drugs that kind of short circuit this behavioral pathway. So we've tried to be sort of very broad and talk about addiction as like all of the different things that you can be addictive behaviors. And so they involve this process of developing like behavioral cravings, and we sort of then match, then meet those demands from our brain. But you can short circuit that process and go straight to the reward pathways. And in many cases, these lead to physiological changes that make it harder to stop using them, i.e. dependence. And then that then leads to withdrawal. So that leads us obviously directly to, drugs of abuse, or, and this is a ranking of different drugs of abuse and their ratings according to some physical characteristic or physiological characteristics. And then here we have, the last two columns are the legal classifications of them. And so, so class 1 in the US is obviously the most restricted drug class. and sort of, well, NS means, like not, restricted. And so does anyone sort of see any sort of relationship between the sort of physical or physiological issues with drugs, i.e. physical harm, dependence, and social harm, and the legal ramifications of them? Like in an ideal world, they'd probably track, but they don't. And, like probably the best example of that is, because it's in flux currently, is going to be cannabis. So it has pretty low, relatively low risk factors in terms of, like its, physical harm, dependence, and social harm. But in the federally, cannabis counts as a Schedule 1 drug. Obviously, state by state, it's, like things are changing now. There are, like things like, alcohol, at least misuse, is associated with significant social harm, and is obviously, not restricted. Drugs like LSD also have very low levels of physiological harm, but very high levels of, like are also sort of class 1, is also a Schedule 1 drug. So we have this, mismatch between sort of like policy and the physiological harm that might be caused by drugs of abuse. Yes?
Wasn't there a study done in the 80s with ecstasy for MDMA where they gave monkeys 20 times the dose of ecstasy and
Killed them?
had holes in their brain?
Actually, I think I do remember that. Yes, I was going to say that I think there have been misleading studies done on every single one of these things, including in the early days, like, oh, heroin was developed as a cough syrup for kids.
Yeah.
Yes, it was called heroin because it was supposed to be the heroic
Yes,
morphine addiction.
yes, exactly. And so misleading studies going both ways date way back. So
I missed the grade age.
yes. Although to be fair, I think the dose of heroin in those cough syrups was actually very low. But yes. But I do like this sort of like slogan, heroin, it's for kids. So when we're trying to think about the potential harm of a chemical substance, like there are a number of things that we're concerned about. So one of them is addictive potential. And so like this is like basically saying, of the people who sample a particular substance, what portion will become physiologically or psychologically dependent on the drug for some period of time? Heroin and methamphetamine are the most addictive by this measure. Cocaine, pentobarbital, nicotine, and alcohol are next, followed by marijuana and possibly caffeine. Some hallucinogens, like LSD, have little or no potential for creating dependence. And so, like addictive potential is one of the sort of key drivers of potential harm from any kind of, drug of abuse or non-medical use, as I think people like to say now. And the cumulative probability of transition from use to dependence a decade after first use was about 15% among cocaine users, 11% among alcohol users, 6% among cannabis users, and 16% among nicotine users, i.e. nicotine has greater likelihood of generating dependence than something like cocaine. Some of that is obviously clearly due to the fact that you can go down to the Hannaford's and buy nicotine, and I don't believe that they sell cocaine currently. But so this is where some of these social factors come in. But so the sort of addictive potential is a major factor in the potential harmfulness of some of these drugs. If we look at the prevalence of drug dependence, we get a kind of different picture. So, for example, marijuana is or cannabis is a much more frequent drug of dependence than cocaine or heroin. Does that mean it's more dangerous than cocaine or heroin? Probably not. It means it's more easily available. And so this was a survey actually before there was this much of this big national drive for legalization of cannabis. And you see that sort of, cannabis is pretty high in terms of the frequency of people reporting past month use. And we have, like some of these other things, like falling down in frequency. And part of this prevalence of drug use in this case is because there is sort of like fairly, like most people are aware that, hence legalization efforts, that sort of, like cannabis is doesn't carry the same level of risk that something like heroin does. Now we're particularly concerned about the illicit use of opioids, especially prescription ones. And here we have a comparison of the effects of addictive drugs in terms of dependence, withdrawal, tolerance, reinforcement, and intoxication. So, for example, here we see that, like nicotine is amongst the most dependence-inducing agents that are around. It's really effective at making people addicted to it. However, doesn't have very strong intoxicating effects. And although it's not on this table, typically no one dies from a nicotine overdose. The only people who do are actually people who are involved in harvesting it because they absorb it through the skin. Something like heroin is very easy to sort of die from, but it doesn't have actually the same level of addictive properties that something like nicotine does. And then sort of, down here we have, alcohol is sort of not so high at generating dependence, but in people who are true alcoholics, they have horrendous withdrawal symptoms. So, like it is right up there with in the scale of physiological dependence. And then we have things like, caffeine, where there is significant levels, like obviously there's no intoxication, I think, but since people even have coffee to sort of try and persuade themselves that they're safe to drive, but we do have like significant levels of dependence. If you will also sort of get significant withdrawal symptoms if you're sort of a regular sort of coffee drinker and try and stop for a couple of days. You'll start having noticeable headaches and so on. And sort of marijuana, cannabis is also similarly towards that sort of like milder end. And so we will finish talking about well, we'll go on to talk about opiates and so on just at the beginning of tomorrow's class.